Today I will be covering expedited data analysis of tabular data, and later on after this session, Lakshmirena will take you in terms of how to do for text. So before we get started, so why do we need to do explorated data analysis? So today, in a typical machine learning lifecycle, what we have, we gather the data, we do analysis, then we train the model, we test the model, we deploy the model, and we monitor the model performances. So before training the model, so we do need to do with explorated data analysis. So what is explorated data analysis? So explore EDA is a process of analyzing and visualizing datasets to uncover patterns, trends, anomalies in the data. So it is an important step before we do anything in terms of like model development. So explorated data analysis. So what we can
Ramay, can you bit little loud? You're good, but still
sure.
little more. Okay, yeah.
Sure. Yeah. So why do we need to do EDA? So in order to understand the patterns in the data, so we need to do explorative data analysis. Patterns. Along with that, for example, uh, if the stakeholder comes and asks a question from the data, so we need to answer what is inside the data. In that way, to better understand the data, we do need to do explorative data analysis. Along with that, to detect issues such as some of the columns or some of the features might might have missing values. So in order to detect issues, some of them have like outliers. For example, if you take in terms of data, any data, so some of the customers, for example, if you take an example of each individual's salary, some of them might earn more, some of them might earn less. So those, the extreme values are called outliers. So in order to detect those issues from the data, we need to do EDA. So in order to test the hypothesis, for example, today I will be, for all the explanation, today I will be taking an example of e-commerce site. For example, there is a company which sells products to customers, pet products such as pet food and pet related things. So that in the USA there are companies like PetSmart, Petco. So these are the companies. So today I will be explaining, and today I will be taking the example of that company, and I will be explaining the whole EDA. So for example, if the stakeholder comes and asks, so how are we doing in terms of dog sales? Okay. Are we selling, which kind of dog food we are selling from the last 15 days? Like, what is the most number of sales? So in order to get the questions answered, so we do need to do EDA. Okay. So this is like hypothesis. They come up with different hypotheses. You have to test, you have to give the results to them, the stakeholders. Okay. Along with that, in order to develop a machine learning model out of the data, so we do need to do EDA. So EDA and feature engineering are the important things before we get into machine learning, any kind of machine learning. So there are like different tools in order to do EDA. For example, if you have data such as, if we want to cluster the data, if we want to cluster customer segments such as who buys more food items, for example, who buys dog food, you want to cluster those customers, and the marketing team want to market for those people. So you have to come up with clusters. So this comes under EDA. For example, if you want to do univariate analysis, if you see here, univariate analysis is like, for example, if we have the data and you want to see how the sales data in the past 1 month. So you are only searching, you are only testing, like you are only finding information in that one particular feature, sales data. So it is called univariate analysis. You can do visualization as well. Bivariant visualization. For example, bivariant is like if you are comparing two different features. For example, there is a concept called churn. What is churn? Customer churn. For example, customer churn is defined as the customer who is not buying or who is leaving the website. That is called customer churn. So you want to check whether the customer churn and sales are, I mean, does the sale has impact on customer churn? Okay, so in that way you can do bivariant analysis. You are comparing customer churn with the sales. If the business comes up and ask a question, so right now we are reducing the customer has been churned, like past month the customer churn has been 5%. So what is the impact of sales? So if they want to dig into that, so how do you do that? It is called bivariant analysis. You can do multivariant analysis as well, like how are multiple features uh, behaving with respect to churn. Okay, so these are like different techniques in terms of EDA. So univariant, along with that, in EDA there is a other concept called like you can do just qualitative analysis, and you can do visualization as well. So you can do univariant visualization, univariant non-visualization, and along with there are different fields. So you can do that. Along with that, this is in terms of EDA. EDA and feature engineering. Next is feature engineering. What is feature engineering? So in terms of feature engineering, extracting relevant information from the data into features is called feature engineering. For example, if you have a data and you are not sure, I mean, so there is a data called, for example, there is a column which has customer information, but it doesn't have like right information. So they have only data in terms of this customer has bought $500, and the next customer they have bought like $600. You don't have correct information, so you use regular expressions and extract the data. So this is called feature engineering. So how do you extract relevant information for the modeling? It is called feature engineering. So in terms of feature engineering, explorated data EDA and feature engineering consists of handling the missing values. For example, if we have customer data, how do we handle the missing values? So there is like mean imputation, mode imputation, median imputation. These are like different concepts in terms of handling missing values. You cannot directly just, you can do removing the missing values as well. For example, if you have data in terms of customer data and you, can you hear me?
Yes, we can hear you.
Yeah,
Yeah,
we can
sure.
hear you, Pranay. Yeah.
Yeah, sorry. So handling missing values one of the important component of EDA. So how do you handle missing value? How do you handle the missing values? Do you want to delete the rows or do you want to impute? So deleting is not advisable because deleting the row means deleting the customer record. So it is not advisable to do that. So then how would you fill those values? So there are like different strategies: mean imputation, mode imputation, and you have to find out the pattern in the missingness. For example, if you have data set, so the pattern in the missingness is like for the past 2 days, you could not able to find a feature age column. For example, there is a column called age. For the past 2 days, you could not able to see the age in that column. So you know that age is most important in terms of features. So you have to find the missingness. So how do you handle those kind of situations? It is called it is one kind of feature engineering. Then outlier detection. As I have explained to you earlier, so there are like different techniques in order to for you to detect the outliers. So you can draw box plots using visualization. You can do Z-score test using statistical tests. So you can come up with domain thresholds. For example, if there is a data set and you have the domain knowledge that above this feature, above this value, these are like outliers. So this is like outlier detection. So you have to come up with a solution to detect the outliers in the data. So there are like different techniques. You can do box plots, Z-square test, interquartile range. So depending upon the kind of problem we are solving and kind of data we are dealing with, we use one particular method. So in order to work with these outliers and come up with better features, so we do feature engineering for that outliers. So one is like log scaling. And there are like different methods as well in order to extract relevant information and use the data for outliers for modeling. So this is in terms of outliers. So there is also a concept called feature scaling and feature normalization. For example, if you take any data, so most of the data is normally distributed. What is normally distributed? Normally distributed is like, for example, if you see the screen here, this graph is normally distributed. So it is not skewed in any direction. Either it is not skewed in right side or left side. For example, if you see here, this data is skewed to the right side. Okay, so in order to deal with that kind of feature, this is mostly used in numerical data. So you do feature scaling. So there are like different methods: standardization, normalization, min-max scaling. So depending upon the features we are using, depending on the kind of data we are dealing with, we do feature scaling. So then there is categorical data. For example, right now we have features. I will also take an example and I will explain you how we do it in a code as well. So categorical data is like if you have an age gender column, male is they the data is filled with male and female, but you have to do analysis. Then you have to come up with numbers, numerical representation of that data. So you can give male as 1, female as 0. Okay. So in that way, you can convert the categorical data into numerical data. So how do we do it? This is called, there are like three different kinds of categorical data. One is nominal data. So nominal data doesn't follow any particular order. If, as I have told you, gender doesn't have any order. Male is first one, female is second. There is no order. So that is called nominal data. Then there is other data called ordinal data, where it has an orderness. For example, if you give reviews 1, 2, 3, 4, 5, or else low, medium, high. So you come up with numbers, right? Low means 1, medium means 2. So it has an ordinal order for the feature. So this is called ordinal data. So how do you handle those? So you can use concepts such as one-hot encoding, nominal encoding. So in Scikit-learn, there are like different libraries you can use to work with this kind of data. Okay, so and you can also come up with different features. For example, the business comes up with a question. Uh, there are like different age customers. You have to group them into different bins such that you want to do marketing. For example, if you take an example of normal e-commerce company, where the company might have customers ranging from 13 years to 60 years. Okay, so you have to convert the data in such a way that you have to come up into bins, teenagers, 20 to 25 years old. So depending upon the age you want to work, the marketing team want to work with the data. So you have to divide the data. So you can do feature transformation and features creation using binnings as well. And there is one more concept called feature interaction terms. For example, if you have price, okay, so the price has like different, for if you have products data and you have information of price for each product, and for a particular month you provided discount for different products. Okay, so you don't want to, I mean, use two different features, but you want to come up with one feature which is providing the most important information for that month. So you can come up with interaction features like price multiplied by discount. So for that month, you can come up with different features as well. So these are like interaction features. Okay. So feature engineering depends upon different criteria. It depends upon the domain knowledge, the team you are working on, okay, the problem you are solving. So depending upon the requirements of stakeholders, you do different kinds of feature engineering. Okay. So, and if you want to come up with aggregation as well, you do feature engineering. For example, you have data from for all the customers for every order, but you want data in such a way that the past 1 year, how the customers are behaving. For example, there is a customer called XYZ. What is his monthly spending? What is his yearly spending? You have to aggregate that data and you have to come up with new features so that a machine learning model can understand. Okay. I mean, so that the machine learning model will be applied. Okay. So depending upon the problem at hand, so we use feature engineering in that way. And feature engineering and EDA is not like one time thing. Okay. It is an iterative process. So for example, you do feature engineering and EDA, then you train a model, but you are not satisfied with the results of the model. Whether you can do classification, regression, or you can predict the churn percentage for the next month, but you are not satisfied with the results. Then you revise the features in such a way that those features capture the maximum pattern in the data. So it is an iterative process. So once you come up with new features, for example, the data engineering team, so they might load a new kind of data. So what happens? So they have one more feature coming up with like profile completion data. So what you have to do, you have to add that feature into the overall data set. So then you train again the model. In that way, you come up with new features and you train the model again and you improve the performance over time. So EDA is like regular process, everyday process. Okay. So for example, if you take any machine learning model, first you do EDA and then you do feature engineering in order to do machine learning modeling. Then you come up with a model. Then it is an iterative process, as I already told you. So what is so EDA and feature engineering? So EDA is like cleaning the data, coming up with the insights depending upon the question the stakeholder is asking. And then feature engineering is coming up with new features and extracting new information from the data. Okay. Then you develop the model. So there are like different tools. As we have learned earlier, Pandas, NumPy is used for data wrangling and data manipulation. Okay. R regular expressions is used to deal with textual data. Matplotlib is used for visualization. So right now you will combine all of them and try to come up with answers for each question. So this is the whole concept is used in the exploited data analysis. So I will be taking an example. So this example, as I have already told you, this is a data set of a company which is into selling products for uh, food for pet owners. Okay, pets. They are working with dogs, cats, and etc. So we will see how we can do exploited data analysis and we can find the insights. Okay. So currently I will be only focusing on these five libraries. Pandas, NumPy, SciPy is used for statistical analysis. As you already know, Seaborn and Matplotlib. These are like different libraries we can use for EDA. Let me load the dataset again. So in EDA, first we check the shape of the dataset. This is like basic steps. As you all, I mean, many people knows this, but still I'm showing it. So so first we load the data. So we load the data using Pandas. Okay. So we use Pandas. This is an Excel file. So I have loaded using pandas.read Excel file. Okay. And I have mentioned the first line as an header. Okay. This is like heading. These are like different columns here. Okay. First, we will see how the dataset looks like. So right now the datasets consists of 7,400 customers data, and there are like 26 different features. So 26 different columns of explaining the data. So I will see header shows us the top 5 rows. See total sales, total margin, total units, total transaction. So UPT, SPT. For, so these are like different fields in the data. For example, if you see here, homeowner or renter, is a customer homeowner or renter, or what is the loyal discounts they got. So this is like different information we got. And there is one more other column called churn, 90 days churn. So in the last 90 days, if they have bought something, so it will be zero. It will be zero, or it will be one, or else it will be zero. So there are like different features we have in the data set. So how do we do the explorative data analysis, and how do we do feature engineering from this data set? I will show you. So first, you will do you will check how each feature is. For example, if you see here, total sales is like float data. You can check the data type of each of the data set, each of the feature. So currently in our data set, we have like 26 features starting from 0 and ending is 26. This is like real-time data, which I am showing you. So right now the team wanted to do customer churn prediction. Okay, they wanted to see insights how the customer churn is doing, like what is the churning percentage of customers. So this is like the main motto of the EDA for this data set. Okay, so here we have the head. So in order to do the qualitative data analysis, you can use like describe. Df.describe shows you how each feature is in terms of. For example, if you can see here is a count. So there are like total to 7,403 customers data. So this is mean. So you can see mean. So the mean of total sales for all the customers is around 500. And STD is like standard deviation, how deviated the data set is. Okay. So what is the minimum purchase of the dataset? The minimum purchase is like 42 cents. So here you can see maximum. So one customer bought in last year around $10,190. So this with using describe, you can do mean, you can find the mean of the dataset, standard deviation of the dataset, minimum of the dataset. Along with that, you can also find the percentiles, how that below 25 percentile are doing. Like below 25 percentile only bought $125. Okay. So 50 percentile, 75 percentile, and maximum. So this is describing the data set in terms of qualitative analysis. So you can also see here. So if you check visit frequency, there is one column called visit frequency. So on an average, a customer visits 10 times. So this is the yearly data set, the last year, for example. So on average, you can find out the information. On an average, the customer visits 10 times the website. Okay. So maximum a customer visited 129 times. So you can find out information just using describe. You can find out a lot of qualitative information just using describe. Okay, right now this data set might contain null values. So in order to check null values, what I did was df.isNull. So in pandas, you can use isNull, and I can sum those null values. So I can see here from the data set, there are no null values in total sales and like all of the 25 features other than estimated home price in dollars. So there is a column called estimated home market value in dollars. Okay. So this column has like 370 null values. Okay. So how do you handle those null values? So that comes under feature engineering. Okay. So right now I will also show you how did I do that. Okay. So and I also want to see the patternness in the null values. What is the pattern? So if you can see here, I have used this is MSNO. MSNO is like missingness. If you can see here, so I have imported C missingness. So this library helps us to understand how the pattern in the missingness. Okay. So if you can see here, the missingness is random. It is not distributed like for one customer or two customers at one point. So that is missingness is spread overall in the data set, in the estimated market value. Okay. So for example, if you want to do any statistical analysis, for example, I want to see the total sales. So I want to analyze total sales for all the customers. I want to come up with like different points, different insights from the data. How do I do it? So here, if you can see here, here I have plotted a visualization graph for the total sales. Okay. So in order to do analysis for total sales, first what I did Z-score test. So Z-score test is used to find the outliers. Okay. So I have used stats. If you can see here, stat. I have imported stats above where scipy.stat import stats. So scipy is a library which is equipped with all the statistical tools in order to do analysis. Okay. So I have imported Z-score from stats and I calculated the Z-score for the total sales. Okay. And I identified the outliers. Okay. What I have found out that was the outliers for the dataset out of 7,400 customers, we have like 147 customers who bought like much above the price and like much above or much below. Okay. So most of the dataset we found out is like they are above the mean. Okay. How much is it? So in order to find the mean, so what I did, outliers mean, outlier dot total sales, and I called the mean. Okay, so first I have identified the outliers. Then out of the outliers, I find out the mean. Okay, so in that way, I found out that the mean of the outliers is 3,427. But what is the average? As we know, the average for the total sales is, where is it? In describe. The average is 497. But the mean for the outliers is 3,600. It is almost 6 times. Okay. For these kind of customers, the company don't want to lose them, right? For like they want to find out the outliers who are buying more. Along with that, they want to give them discounts. So okay. So in that way, you can derive insights. And I have used like simple visualization to plot this graph. So what this graph shows us. So this graph, you can identify many patterns, like many things from this data. For example, if you can see here, the outliers are above the average value. Okay, the average total sales is around 500. Okay, but the outliers are all above here. Along with that, most of the customers, okay, most of the customers are what is the, okay, let me show you what is the index I have put. I have plotted it total sales with the number of customers. Okay. So the number of customers who bought is almost near to 2000. Okay. So the outliers accounts for like 13% of the overall data set. Okay. So this is one kind of getting the information in terms of how to handle outliers and how to get the outliers data. So if you want to see the top 10 percentile, okay, like if you want to identify the top 10 percentile, how do you do it? Okay, so you can use just quartile 90% and then you sort out the data set. So you take the whole data and you extract the top 90 percentile and you just remove them. So the top 10% people by around like 1942. So you got the answer. See here, 1942. So here from the analysis, what we have found out that there is a wide variation in total sales. So where we know that the standard deviation is 630 and the mean is around 500. But for the 147 outliers, we found out that the mean is around 3200, which is like huge. So this is one kind of doing analysis through EDA. So I will show you one more example. So this is like same thing, but this is for total margin. So total margin, what is total margin? Total margin is the profit we made from the total sales. So that is called total margin, right? So total margin also is something similar like total sales. If we have more sale, then we have like total margin is also same. If you can see here, the total margin also accounts for same thing, like the distribution, the outliers, everything is like similar. See, right now in total sales, we got around outliers around 147. In total margin, we got around 148, which is also same. Okay. And one more thing I will show you. What? Okay, so right now we have information, right? So right now we know that we give discounts as well for the customers, but we want to find out the customers whose margin, like we did not get any profit from them. How do we do it? For example, if we have the data set here where we have total sales, total margins, and we give them loyalty discounts and everything. But we want to find out information such that where we give discounts and we lose the money. So in order to find that kind of information, for example, the stakeholder comes up with a question. So right now we are giving a lot of discounts. Can you try to find out the customers whom we are losing money? Okay. So in order to find those customers, so you use Pandas to do data wrangling, and then you try to find out the information from that data. So right now, what I have found out through EDA is, so there are like total 32 customers whom we are losing money, and the money is around minus $35. So they are buying products from us, but at last the company is losing money for those customers. So then what happens? That I mean, like marketing people can decide like, do we need to continue giving them discounts or not? So this is like one question that team might come up with, or the stakeholders might come up with. Okay. So this is like one more question the stakeholder has come up with. Like for example, right now we have like different customers. Is every customer signed up? Okay. So did they fill what kind of dog do they have? What kind of breed do they have? What kind of products they want to buy from the company? So they have, while signing up, you can answer some questions, right? there might be some questions which are optional. You can write or not. So, but what happens? The team want to see how many people have filled the profile completion question. Like we have a data feature called profile completion. Okay. So then the stakeholder might have asked like, so how many people have really completed the profile completion? So if they ask such kind of questions, you just do EDA. You try to find out how many people have completed the profile. So you just then sum up and you divide with the whole number of length. So then you can answer this question. So right now, only 61% of profiles have been signed up. Okay. So why is this important? For example, if you have profile completion for all the customers, what happens? So the recommendation team, recommendations like marketing team, recommendations team, sales team, they have information like for the products, right? Some people have Labrador, some some customer has like Chihuahua. So depending upon the pet they have, they can do marketing campaigns. Okay. So right now they have found out that only 61% of people completed their profile completion. What the team might do, so they want to increase the profile completion to like 5% for the next month. Okay. So in that way, on a regular basis, you have to find out this information through EDA. Okay. So I will be showing you one last question. So which is in terms of how do you impute the missing values? As I've already told you, so there is a column called estimated home market value in dollars. Okay. So the stakeholder might ask you like, please fill this missing values. I don't want to lose this customer's data, but you have to fill these missing values, which makes sense. Okay. What you can do. Yeah, this is a question I was asked. Like, this is a question. For example, you want to fill the missing values with sensible values in estimated home market value column. So what I did, I have gone through all the columns that has influence on the estimated home market value. Okay. Then I identified 2 to 3 different columns. Okay. So for example, if you take home market value, so after talking with the domain experts, you know that population at the city and maximum, like there are like different features which can help you to find this information of this data set, like this feature. Okay. So right now you talk with the domain experts and you found out that 3 features influence this feature. Okay. So these are the 3 features I have found out. Then what I have to do, using those features, I have to fill the missing values. Okay. So right now I have used machine learning in order to fill the missing values. But right now, I don't want to go in depth of how I have used machine learning, but simply identifying which features influence this feature, and then how do we do it? I will show you in like in simple steps. Okay. See, for example, the estimated home market value, first, the feature was like this. They were not sure what is the range of the house price. It might be 350K or it might be 400K. So what I did, I just took the mean of each feature. Okay. Then this is called feature engineering. You want to come up with a value, you can do machine learning or EDA. Okay. So right now, this feature which I have a range, but I want a numerical value. What I did, I just did mean of that. Then after finding the mean, what I did, I separated the data set in such a way that missing values is in one data and remaining are in other data, like other data frame. Okay. So once I found out that, I have already told you there are like different features which can influence the house price. So I have already identified 4 features which influence the estimated home market value. Okay. So out of those features, I did random forest regression. So what happens? This regression, it just predicts the house price of the missing values. So I have just used machine learning in order to do that. You cannot do normal mean imputation for every kind of feature depending upon the data set. For example, some customers might be living in a rural place. Okay, so you have to fill the house price in such a way that the house price should resemble the rural place house price. Okay, for example, there is one more customer who lives in urban, so you have to fill the house price in terms of urban house price. So in that way you can do that. So machine learning helps us to fill those missing values. Okay. So I have used a random forest regressor to fill those missing values. So this is one kind of handling the missing values. For example, if you have simple, I will show you, I will take an example from here. Okay. For example, if you take in terms of like, if you have like time series data, okay, I don't have an example here. For example, if you have time series data, if you have stock market of stock price of Tesla. So right now you have column like at 9:15 it was around $350. 9:15. 9:30 it is around $360. But you are not sure, you don't have the price at 9:25. How do you do it? So you just use mean. Okay. You can also do backfilling, forward filling, like different things. So depending upon the kind of data set you are dealing with, you have to choose which kind of feature engineering technique or which kind of technique to choose use, and you have to come up with answers for that. Okay, I will show you one more example, one more question. For example, one more question is, so we have like different species we are catering to, like dogs, multi-species, dogs plus cats, specialty. So right now the stakeholders want to come, I mean the business people want to know how many customers are buying dog food. Okay, how many customers are buying multi-species food. They want to get numbers. How do you do it? You just use species group count. You call the feature and you just ask value counts. Okay, you also try to find out most common species, least common species. So least common species is dog or cat. Okay, there are only like 3. So you don't know which, like depending upon the customer, so how they fill the data. So it shows the answer. Like most of the people are like dog. So if you can see it, so dog has like lot of the customers buy dog products. Okay. Up next, multi-species. Multi-species can be snakes, rats, reptiles. It can be anything. Okay. Some people buy dog and cat. So depending upon this information, the business can act. So, but you have to provide this information doing exploratory data analysis. Okay. Yeah, that's it from my side today. Thank you.
Thank you for watching. Please like, share and subscribe to KKR Gen AI Innovations channel.